Although we have studied some aspects of glaciation in class, this video aims to focus on the meltwater features of glaciers, Fluvio glacial landforms.
On a fine summer's day, walking and climbing in the mountains can be a warm business. Areas with cold climates often have high temperatures in the summer. This seasonal difference in temperature affects mountain glaciers.
Ice can melt along the glacier, although the rate of melting, or ablation, is greatest towards the snout. Rates of ablation vary throughout the year, reaching a maximum on summer afternoons.
Melting glaciers release large amounts of meltwater. This may form streams on top or along the side of the ice. Meltwater can disappear down crevasses and then flow under great pressure and at high speed. This means that they can carry a large load of rock particles. When the meltwater reaches the glacial snout, it usually slows down and drops much of its load, thus changing the landscape by deposition.
One such landform is an outwash plain, which may stretch for hundreds of kilometers from the ice front. They consist of sands and gravels carried by meltwater streams from glacial moraine. The surface of the plain is often hummocky and cut by several wide, braided meltwater channels. Sometimes there may be small ponds, called kettle holes. These are formed where blocks of dead ice slowly melted, leaving depressions in the outwash. The outwash plain is sorted because the larger rocks are deposited first, and the finer material is carried much further. The outwash will also be in layers, stratified, with each layer representing the material deposited during one season's ice melt.
Another example of a fluvio-glacial landform is an esker. An esker is a long, narrow, winding ridge of sand and gravel. It may meander for several kilometers across a glaciated area and may be up to 15 meters high. It marks the course of a subglacial stream channel and represents the deposition of sediment on the channel floor.
A kame is a small mound of sand and gravel. It may be formed by material deposited in crevasses by meltwater streams flowing across the surface of ice. As the ice melts, the material subsides to the ground.
A kame terrace, however, is formed by the build-up of sediment in meltwater lakes and at the glacier's edge. After glaciation, the kame terrace appears as a ridge running along the valley side. It may be confused with a lateral moraine, but analysis of the material should easily reveal its true identity.
We hope that you have learned something new and interesting.
Please leave your comments below and subscribe for more enthralling geographical phenomena.